Okay, tutorial 1, question 4. Sarah has saved some money, 500 quid, for buying a new smartphone. She is considering to delay the purchase for 2 years and invest the money in the bank that offers to pay annual interest of 4.75 compounding quarterly. Suppose that the price of a smartphone will increase to £550 in 2 years. Okay, that's the setup. Will Sarah be able to buy a new smartphone after 2 years? Okay, so this problem is all about finding the future values. So firstly, calculate the future value of the £500 in 2 years. If we do that using the usual formula, so 500, 1 plus the interest rate is 4.75%. That's compounding quarterly for 2 years. Okay, if we pop that into the calculator, is this enough to pay for the smartphone of £550? Well, the calculator gives £549.52. So the conclusion, Sarah will not be able to buy the new phone. Okay, she falls short by several pence, 48 pence. Okay, part B. Calculate the real rate of return for this for the investment in the bank. So the real rate of return, we need to use Fisher's equation, which says 1 plus the real rate of return is 1 plus the actual rate you get in your hand. If we're going to use annual compounding, it'd be the nominal rate. Anything else, we need the actual interest you get in your hand. So we need the effective annual rate. Okay, so we take what you actually have in your hand and we discount it by inflation. This is Fisher's equation. Okay, so we need to find the real rate of return, which is R, big R. And to do that, we need the rate of inflation, I, and the effective annual rate. So let's start with inflation. Well, we don't have any national statistics, we just have a smartphone. So we're going to use the change in value of the smartphone as some estimate for inflation. So the smartphone has increased in value from £500 to £550 in 2 years. Okay, so using this as this product as a way of calculating inflation, we're going to assume the inflation is constant over the 2 years. What we find is the 500 quid inflated over 2 years gives £550. And from this, we can estimate inflation. Okay, so I'm going to divide through by 500. I'm going to take the square root and subtract 1, and I have an approximation of, if we pop that into the calculator, 4.88% of annual inflation. Okay, so there's my rate of inflation, my little I. Next, I need to calculate the actual interest in hand, the effective annual rate with this quarterly compounding. Okay, I think I'll go to the next page, give myself some room. So interest is billed in quarterly. So we need the actual interest received the effective annual rate, and to do that, to calculate this, we use the following equation: 1 plus the effective annual rate, so that's the compounding factor for some present value, is equal to 1 plus the nominal rate divided by m, all to the power m. So all these individual compounding periods in 1 year. Okay, and we compare that with a single compounding period. So we need some rearrangement using the numbers we have. Okay, we have the nominal rate is 4.75%, compounding quarterly. Subtract the 1. From this, we find the effective annual rate is approximately 4.835%. And now going back to Fisher's equation, we can drop all these numbers in, and we find that the real rate of interest is 1 plus some of these numbers we calculated, 0.04835, and there's some other numbers. We should use the exact number in the calculator. Rate of inflation was 488, and there were some other numbers on the end, some other digits. Take away 1. Okay, using the exact numbers in the calculator, we get a real rate of interest of a negative 0.000435, or we have negative 0.0435. So in fact, your savings are effectively going down due to rising inflation and interest not keeping up. So there you go. There's the solution to this final problem.